Hi, this is Raina Fitzgerald, and in this lesson we're going to look at graphing linear equations. Here we have an example of a linear equation, and we're going to graph it on our Cartesian coordinate system. To do this, we're going to find the x and y intercept. When we talk about the x-intercept, we're talking about where on the x-axis that our line will intercept. Let's put some tick marks in, and I'm actually going to adjust this just a little bit. Let's move our x and y axis a bit, and let's put our tick marks in. So this represents 1, here is our x location of 2, an x location of 3, and an x location of 4. We've got our origin, which has an x location of 0, and here's a -1. Now let's look at our y-axis. We start with a y location of 0. Here's a y location of -1, y location of 1, 2, and here's 3. We'll put one more in. Here's 4. So when we're talking about an x-intercept, let's find that first. What is our x? I'm going to abbreviate it as xint for our x-intercept. Well, if we think about our x-intercept, it's some point that the line intersects on the x-axis. So if we intersect the x-axis when x is 1, y has a value of 0. If we intercept where x is 2, y has a value of 0. And if we intercept where x has 3, y has a value of 0. So our x-intercept will have some x value in its ordered pair, and the y value will be 0. So let's put a 0 there. Okay. So what we need to find then is we need to find the value that goes right here, the x value, when y is 0. So let's take our original equation and change the y value to 0. So our original equation is 3x plus 4 times y, and we want to know what is x when y is 0. Well, 3x plus 4y, or 4 times 0, is 12. Let's find the corresponding x value. Well, this value here, 4 times 0, is 0, so it basically goes away, and we end up with 3x equals 12. Now, to balance this in solving for x, we'll multiply both sides by 1/3, and we'll get x equals 4. So this means that x is equal to 4 when y is equal to 0, and let's go put that point in. And here is the point, x is 4, y is 0. Now let's find our y-intercept. I'll do this in a different color. So we want to know what is our y-int, or abbreviation for intercept. And if we think of the y-intercept, we're looking for some point along the y-axis. Well, if when y is -1, x would be 0. That puts us on the y-axis. 0, 0 puts us on the y-axis. The point 0, 1 puts us on the y-axis. 0, 2, 0, 3, 0, 4. So if we're sitting on the y-axis, we are a point on the y-axis, our x value will be 0, which means that any y-intercept will have an x value of 0 and some y value, and our mission here is to determine what is y when x is 0. So let's work that out by taking our original equation, 3x plus 4y equals 12. But we're going to change the x to a 0. So 3 times 0, because x is 0, plus 4 times y is equal to 12. Now, 3 times 0 is 0, so this goes away, and we end up with 4 times y equals 12. Now we want to solve for y, so keeping our equation balanced, we'll multiply both sides by 1/4, and we get y is equal to 12 times 1/4, or 12 divided by 4, which is 3. So this means that when x is 0, y is 3. So let's put a 3 in here. And then our y-intercept is when x is 0, y is 3, and it's right here. So What we have here are 2 points. We've a point at 4, 0 and a point at 0, 3. And you may know this already, but Euclidean geometry tells us that it takes just 2 points to determine a unique line. So by connecting these 2 points, we have our line 3x plus 4y equals 12. Let's connect those points. So I'm going to start up here, go through the 3, come down, go through the 4. This is freehand here. So here is our line, and this is the line 3x plus 4y equals 12. Here we have an example of a line, and this is in the form y equals 2x plus 3. This is not standard form. This is actually called slope-intercept form, which we'll look at later. But for now, what I'd like to do is graph this line by finding 2 points on the line, and I'm going to write the points down below on my t-chart. So let's find the value of y when x is 0. We'll use blue. When x is 0, y is equal to 2 times 0 plus 3. 2 times 0 is 0, 0 plus 3 is 3. So this point is the point 3, 0. So when x is 0, y is 1, 2, 3. That puts us right here. This is the point when x is 0, y is 3. Now I'm changing colors to red, and let's find the value of y when x is negative 1. So, what is y when x is negative 1? It's 2 times x, or 2 times a negative 1, plus 3. Well, that's equal to a negative 2 plus 3. And a negative 2 plus 3 is 1. So our next point is when x is negative 1, y is positive 1. So our point is right here. This is the point. X is negative 1, y is positive 1, negative 1, 1. Let's label these tick marks. This is x is negative 1, this is y is 1, and here we have x is 0, and here y is 3. So if we connect these points, we have our line. Here's our line. This line represents the line y is equal to 2x plus 3. Here, we're going to look at horizontal and vertical lines. Let's start by drawing a horizontal line. So I'm drawing it down below. This is a horizontal line, and I'm going to move it onto my graph, and here my horizontal line is y is equal to 0. Here my horizontal line is y is equal to negative 1. Let's move my horizontal line right up, well, we'll put it down here, and let's put some of the tick marks in. So here y is, actually let's go get, y is negative 1. Here y is negative 2. And we'll put a negative 3 here. Here's where y is 0. And then we have y is 1, y is 2, y is 3, and y is 4. Now if I move my horizontal line, let's go get our blue horizontal line, and if I put it through 4, this is the line y equals 4. If I move the horizontal line down here to 3, this is the line y equals 3. Notice that when I do this, all values of x exist for this line. So I have an infinite number of x values for this line, but y for this line is always 3, no matter what. So let me go ahead and let's move it down. And here is the line y equals 2. Here is the line y equals 1. And here's the line y equals negative 2. So we can really put this anywhere. Let's put it here. And we'll say y is equal to negative 2. So this is how we write the equation for a horizontal line. The basic equation for a horizontal line is y is equal to some constant c. And the constant c is a location on the x-axis, on the y-axis that this line goes through. Now let's take a look at vertical lines. Here I've drawn a vertical line, and if this vertical line goes through 5, this is a line x equals 5. Here, this is a line x equals 4. And here, x equals 3. I could bring a line all the way over so that it goes through x equals negative 2, and now my line is x equals negative 2. Let's put our line at x equals negative 3, and we'll leave it there. So this is the line x is equal to negative 3. For this line, x only takes on the value of negative 3. Y, on the other hand, can have an infinite number of values. We can be at this point, which is negative 3, 4, or this point, which is negative 3, 3, or this point, which is negative 3, 2. So this line has points that contain all values of y, but x can only be negative 3. The formula for a vertical line is equal to x is equal to a constant. It is a vertical line that goes through the value c on the x-axis.